This video is on topic 7c, solving quadratics using square roots. So how does complex numbers matter with quadratics? Tying it all together, we're going to solve quadratics using a square root method. So to do this, we would solve it in the same manner that we're used to solving any old equation, and that's to isolate x. We need to get x by itself. Once we isolate x, we'll take the square root of both sides, and we have to remember the plus or minus. So imaginary numbers always come in pairs. Just like your eyes come in pairs, you have two eyes. Think about eyes with complex come in pairs. So if I have some complex number 2 plus I, that's really going to have the 2 minus I as another solution. So imaginary numbers will always have their conjugates. And then after that we simplify our square root. So problem number 1, first we isolate our x squared. So I'm going to divide by 3 first. And we'll get x squared equals -7. Next step is to take the square root of both sides. So when we do that square root, we get x equals plus or minus. Right off the bat, the act of taking a square root gives you both options. And the square root of 7 isn't going to be any nice pretty number, but the square root of that negative gives us the I, just like from topic 6c. So we get plus or minus I root 7. That is two solutions. It's super important that you realize that that means positive I root 7 and negative I root 7 are both answers to this quadratic. Problem 2, we start the same way of trying to isolate our x. So I'll get 3x squared equals 40. And then we want to divide by the 3 on both sides. So we get x squared equals 40 over 3. That's not going to be a nice pretty number. And now we're going to take the square root, and when we take the square root, we get the plus or minus options. So plus or minus the square root of 40 over 3. I do not see a negative inside, so this isn't actually an imaginary number. It's just going to be weird numbers. And before we can call this an answer, we need to get rid of that square root in the bottom. So we're going to do that by multiplying by the square root of 3 on the top and bottom. So we'll get x equals plus or minus the square root of 120 over 3. And then we'll try to simplify that 120. So that's going to be a 12 and a 10, 3 and 4, 2 and 5, 2 and 2. So all these prime numbers. And I look for pairs. I see a pair of 2's. So that tells me that we'll get a plus or minus 2 on the outside, square root of 3 times 2 times 5, which is going to be 30 over 3. And that is our final ridiculous answer. This next one is a little bit of a thinker. So if we want to isolate our x squared, I feel like we need to distribute that 2 on the right side. So we'll get a 3x squared minus 7, and then 2x squared plus 6. And if I want all my x's on one side and all my numbers on the other side, then I would need to subtract the 2x squared. So that way we get just x squared minus 7 equals 6. And we want to keep isolating our x squared. So we'll get x squared equals 13. And now I can take the square root of both sides. And we'll get x equals plus or minus the square root of 13. And I know that 13 is prime, so that's got to be our final answer. There's nothing more to simplify there. I want you to try number 4. Pause the video now and get to work. So to simplify this one, we'll have a -1 and 18, which is 9 and 2, and 3 and 3. So this is going to give us x equals plus or minus 3i times the square root of our 2. And that is going to be the final answer for number 4. Number 5 actually has the squared, not just with the x. So the first thing we want to do is at least isolate that part. So get rid of the 2 out front by dividing, and we'll get a 4 on the right side. Now, I don't want to multiply this left side out. That would be such a pain. That would be just too much work. But what we can do is get rid of the squared right now. And we'll get x minus 3 equals plus or minus 2. So once you do the square root, you get the plus or minus. That's super important because now we have almost 2 different equations. X minus 3 equals positive 2, or x minus 3 equals -2. And I hope you're thinking, this is a lot like absolute values, because it totally is a lot like absolute values. So we'll solve both of these mini equations. In one of them we get x equals 5, and then in the other one we're going to get x equals 1. So we get two answers just like before. They just don't happen to be crazy irrational numbers. It's just 1 and 5. So try number 6, same method we just did for number 5, and then check back with your answer after you pause the video. First thing I'm going to do is multiply by that 3, get rid of the fraction out front. Then we can take the square root of both sides. And we would try to simplify the square root of 21, but that's just going to be 3 and 7, so there's nothing we can actually do to simplify it, so we'll just keep it like that. But now we have these two different equations. So if I were to try to subtract 5, and I can't really do anything with the square root of 21, then it's almost like one of our complex numbers, where I would put the negative 5 plus or minus square root of 21. And that is going to be a totally acceptable answer. It's not pretty, it's not cute, but it is an answer and it is accurate.